I have worked at the Laboratory of Tree Ring Research since 1958, excuse me. Came to Tucson in 56. Started in the tree ring lab in 1958, have worked there, retired about 15 years ago, and have been working on a part-time volunteer, what have you basis since then, including working with the bristlecone. But in that time period, I worked all over western United States, all of northern Mexico, in Alaska, in Chile, Argentina, New Zealand, Australia, Sweden, Finland, Morocco, and I have worked with material and worked with people from all continents except Antarctica, which trees are sort of short. But I've worked with material that other people have brought me from places like Greenland and Nepal and China and Tibet, as well as other material here in the western United States and South America and other countries. And originally I started out as doing archaeological tree rings, and if I had stayed doing nothing but archaeological tree rings, I would have stayed working strictly in the American Southwest. And having shifted to, quote, modern studies, I have been able to work all over the world. My interest really is not in ages of particular trees, but in working up long chronologies. I like to work up chronologies that are in the thousands of years range. And the majority of big old trees that you see if you travel around were, well, here in southern Arizona, you go in our mountains, you see big trees, they're 300 or 400 years old. So you have to look for the ones that are thousands of years old. And what I am doing with the bristlecone is we're far beyond the oldest living trees, because I'm working with the dead material, the logs, the remnants, the snags, which were alive long ago. They lived, they died, but the wood is still there. The wood cross dates with each other, and you can work up through starting with the living trees and just going further and further back in time. And we currently go back for 8,827 years, and then we have a gap, and according to carbon-14 dating, the gap is probably no more than about 150 years at this point. And then we've got another 3,000 years that is, quote, floating in time, because we can't tie it into the present. And that's what I'm trying to find, is the piece that will overlap our current chronology, have all the rings that we're missing in between, and overlap with this 3,000-year floating chronology. And then when we get that, we'll have 11 to 12,000 year long chronology. And that is a weather record. And a tree is a recording instrument, and it's just that we are learning how to read that record, and we can do some things very well, and the thing that we do the best is reconstruction of past precipitation, rainfall, snowfall each year. We are working on getting temperature records from the trees, and each tree ring within it holds many other records, and I can provide that material to other people who can study it for things like trace elements that are laid down in the various tree rings as the cells are being formed. The tree is pulling stuff in out of the atmosphere and incorporating it into the trees. And I can't do the work with that, but I can provide the accurately dated samples to other people. I went to Morocco in North Africa a number of years ago because they were having a major drought, and they looked up to see how frequent did droughts of this magnitude occur, and they discovered that their weather records started in 1945. So they could have asked an elderly gentleman and gotten records that were not written down. So they asked us to come to Morocco. I went on 3 days' notice, ran around the country in a Mercedes from the Palace with a driver from the Palace. They tried to show me every tree in the country, and we found that the Atlas cedar, which grows in the middle and high Atlas, is a superb tree ring record, and I worked up a 1,000-year-long high-quality rainfall record for them from that. I worked out the chronology, did the dating. Other people do the computer analyses to work out the actual amount of rain each year, but it came out high quality, very good. The king was extremely pleased. So a couple of years later, I went back with a graduate student from Morocco, and we're on the first trip. We were in a Mercedes from the Palace, driver from the Palace, staying in the best hotels, that sort of thing. Second trip, we were in a very ancient Land Rover. We stayed in third-class hotels, slept in deserted buildings. I enjoyed both trips just absolutely. They're so tremendous. People are very nice, great tree rings, and science can be most interesting at times. This is a section from a dead tree that was growing in Northern California near Redding, California. And this was in a land case. People are frequently suing each other over property lines, where were the lines, this sort of thing. And right here is the scar that was left by the original surveyor in the 1880s. In 1881, surveyor came through. The tree was only so big around at that time. He took the axe, he cut a small section off the side of the tree. He would have scribed it with engraven letters defining where this was on the surveyed line. And then he walked off, and the tree healed over. You can see where the rings are coming over and healing in. They sealed it in and then grew and left just this little dimple on the side of the tree. Surveyors much later came by trying to relocate the original line. They found this tree with this dimple. They said, aha, this could be it. They cut into it, and here was the scar. That you do not get a straight cut like that except by an axe. On the other side, that might show up a little bit better. So there. And we can date this to the year in which that was done. In this particular case, it followed the growing season of 1881, and it was before the growing season of 1882. The survey was done, the original surveyor came through in December of 1881. So this was used in a court case to establish where that line really was. This one is from a different court case. This was in western Texas. There was a ranch that was split up into ranch estates, small places where people could buy and build their houses. And it turned out that the surveyor who split it up used the wrong survey line. So everyone who had bought land and built their house, their house was actually on someone else's land if you went by that new survey. And this was part of the determination of where was the original survey. The survey was originally done in 1917. This fence was built. This is barbed wire. Comes in. Was nailed to the tree when the tree was only so big around. The tree has then grown around this, completely sealing in the scar, the wire, the whole business. But we can tell you when that nail was driven into the tree because of the damage that it did to the tree. And fortunately, the judge at the conclusion of this case, when they agreed that this was the original line and the other line that they had used was wrong, just ordered a resurvey, so everyone wound up owning the piece of property that they thought they had owned the whole time. But many court cases occur each year in which tree ring evidence can play a major part. And for some reason, when there's a few $1,000,000 at stake, people get all excited about it, and so they hire people like me to come and help prove where the original survey line was. And one of the things that has happened over the years with surveys is people wanting a little additional land have been known to go out and move the original survey marks. They will cut them off of the tree, and then they will go to another tree and scar it the same way that the original tree was, only the new place will give them more land. And we can date those and say, aha, this was not done in the year that the original survey was. This is a later fraud. I was involved in a court case in California a few years ago where some guy was stealing a National Forest Service campground. No, he's now in prison. But what he did was he got a bit of private land next to a Forest Service campground that they had just built, and then he went out and marked some trees, said, oh, look, this is where the boundary really is. Thank you for the campground. This is a photograph of a sample that we collected this summer, which happens at this point in time to be the oldest dated piece of bristlecone. So this is a log which was lying out on the ground, partially underground. You can see the dark where it was underground. We're putting glue on one edge because that's where the earliest rings are. And we're trying to preserve those when we're going to cut into the tree. And here is the chunk that we cut out from that tree, from that log. And you can see right here part of the glue that we were putting on there. And there's more glue here. So after that dried, we went in and we cut this out. And this has the earliest dated tree rings, which are right here. That doesn't mean that there aren't earlier pieces of wood. We just haven't found them and dated them yet. And if you look at this, these rings come on over through here, which is why we're trying to save this little batch in here. And that's over 8,800 years ago. The inner date is minus 6,827, which is 6,827 BC, but we prefer to use the minus rather than the BC. And you can see where this part was against the ground, it's rotting away, but the rest of this is good, solid, hard wood, would have stayed out there for thousands of more years had we not come along with our saw. So we're collecting this stuff and trying to push our chronology further and further back in time. And this piece represents an extension of about 127 years over what our chronology had been prior to this summer. And I regard this as a major thing because it's been 25 years since the last piece this old was found. As it turns out, when I went back to collect this, we picked up another piece, which was also back in that time period. Wow. Totally different. The stuff I am working with is no longer living trees. These are just dead pieces of wood lying on the ground, and we will cut our section out, and then I'll bring it back and run it through the bandsaw, make it even so it will fit nicely under the microscope. But I have to be able to see the rings, and there are a couple of different ways that you can do that. You could sand this down, but that's long and tedious. You can take a razor blade. These are the type of razor blades that they use for cutting carpets. So if they're installing a carpet in your house, they will use a razor blade like this, industrial razor blades. And you can take these and just scrape. And pretty soon you've got a surface where you can see the rings clearly, plainly, distinctly. And we look at this under the microscope, and you've got this nice surface that you can work on. If you don't like to do that, you can take a razor blade, nice and sharp, and just cut right along the edge. And then I will take a piece of very fine grained sandpaper. This is 500 grit, and a rubber backing. And I can sand that down, which makes a nice smooth surface and clear. And using another high-tech piece of equipment, I can clean that off, look at it under the microscope, and make a plot of the rings that's here. And I will plot 230 rings or so, because that's 2 of my strips of graph paper. And then I will put that on my computer and run it through, and in 9 times out of 10 it will come right up with the date. Since I am interested in a time period that is over 6,800 years ago, anything that is less than, well, no, excuse me, I'm always making that mistake. 6,800 BC, or 8,800 years ago. Anything that's less than 7,000 years ago, I date just enough to see where it fits, to know that there aren't going to be enough rings to go back to the time period I'm interested in. Enter it into the records, put it into the box, and then I'll never look at it again. Somebody else in the future on some other project may desperately need material that will cover that time period, and they can look in this record, they can pull these out, and they've got them ready to go with a head start, and that they know that that's where this piece of wood would date. And at this point I have no idea where this one dates, so I would have to plot it using the microscope, using my little strips of paper, making a value judgment as to the relative width of each ring in relation to the rings that are adjacent to it. So if I'm looking at it under the microscope, I'm looking at a small section, and I'm looking at the widths of the rings, and I am giving value to those that are narrow. Now, when you get 100 rings to the inch, they're all narrow, but some aren't narrower than others, and it's in relation to the ones on either side. So you give value, and this, we create what we call a skeleton plot. I put the skeleton plot on the computer, I run it against the master, and usually comes right up. This is a Swedish increment borer, which is the tool that we use. And this one has been hacked and beat on. That fits together. It's hollow. It has a sharp tip. It has threads. It's hollow inside, but the tip is slightly more constricted than the rest of the inside. So once it's cut, the core that it cuts is, in theory, floating freely inside, not binding. And as you go up, you push this against the tree, you start turning, that pulls it into the tree, you go into the depth that you think you want, or as far as you can. You insert the spoon, it wedges, you back this out, that breaks the core off, you pull this out, and the core is lying on the spoon. But the core is delicate. So are the tips of these, so you're always careful about how you put them back together. Keep them enclosed. Cores are delicate, so we carry them in the field. We put them inside of a paper soda straw. Now, paper soda straws are difficult to get nowadays. They're all plastic, so we reuse many of these. time after time after time. And I didn't mount this one because it's twisted, but we can get it out and see what it looks like here. You put, if you're in wet conditions and it's wet wood, it'll mildew inside of plastic straw. Paper straw, it'll just come right through and dry right out. So here's a core, and we can write on it in the field, tell what it is, but this is delicate. So this one was tree number 03922A, which means there would be another core, which would be B. It was collected in 2003 from Methuselah Walk on 7/22/03. And we will put all that data into the database. We will glue this into a wooden stick, which we will also write on. We put a bead of glue in there. We put that in like that. We press it down. We will wrap it tightly with string so that it will dry and hold. And then we can carry this and hold it, and we're not going to break it and have it fall into a bunch of little sections. So that's the core. Cores are then, take a razor blade and you take the very top off, you sand that down so you can see, but you can handle, you can write, and this one has a date of -1200 right here, -1100, -1000, 900, 800. So this was, inner date was -200. So there is 1,000 years of record between my two fingers in this one core. This is a lot easier to handle, to bring out of the field, to carry in your pack, than taking a big saw and cutting a big chunk all the way through this piece of wood. All the record is here. We know what it is. If this had turned out to be an 8,000-year-old specimen, I would go back with the saw and I would get a bigger, better sample. But for just the identification of where that particular specimen fits in time, this is fine. All of these cores were collected by Schulman off of Blanco Mountain, and since I was going back to work on Blanco Mountain this summer, I pulled his cores out to see what kind of chronology do we have, what's the dating, is it a good site, a bad site, and it's actually a very nice site. And he would have spent a lot more time working there had he lived longer. But you don't plan on having strokes and dying, so alas. But what happened is many of these have never been looked at. He collected them, he mounted them up, and never had a chance to even put a surface on them. And so I have gone back and pulled out many specimens that he collected, and I'm now working through those. His end of the project finished when the day that he died in 1958, but I'm still here. I'm still able to work these things up, and it's slow, but I will get it done. And in fact, I intend to do a major project on this particular mountain. Trees are recording instruments, and they are recording all sorts of things, and they make the world's longest rain gauge record that we have at this point. Right now, the Tree Ring Lab has done a lot of work over the western United States, so we have literally hundreds of tree ring sites, most of which are in the 300 to 400 to 500 year long range, but there are a number of them that are in the thousands. But if you look at all of these as each site as an individual rain gauge, then you can reconstruct over the last 300, 500, or 700 years, whatever the length of the record happens to be, what the storm patterns were across the western United States. So we can tell you where the storm tracks used to go, and if you know where the storm tracks are, you can determine what the sea surface temperatures are in the western Pacific, which determines where those storms go. And therefore we have a very long record of drought and high rainfall time periods. The El Nino shows up very nicely with our tree ring records. And climate is something that has a huge effect on what we do, where we plant, what we grow, and what you can plan for. So among other things, with tree rings, we can push stream gauge records further back in time. And a major instance is most of the Southern California, Arizona, Nevada area depends on Colorado River water. There, in the 1920s, I think it was, they did a big law case, and they split up the amount of water from the Colorado River, and each state got so many acre feet per year based on their stream flow records. Tree rings show that that record was some of the highest rainfall, stream runoff in the last several thousand years. So they used an artificially high average to determine who got what amount of water. And now we're in the midst of a major drought going on 7 years. The average flow of the Colorado River is way, way down, and there isn't enough water to go around. If they had used accurate tree ring records, reconstruction of stream flow, there wouldn't be as many law cases going on as there are now over who gets how much water. And when you're planning on building your subdivisions and you need the assured water supply, if you use the wrong data, you're in big trouble. We can date volcanic eruptions. So using Bristlecone Pine in the White Mountains of California, we have dated the eruption of Santorini in the Mediterranean, which was the volcanic eruption that took out the Cretan civilization and is probably the basis of the myth of Atlantis. And we can put a firm date to that. We can date earthquakes, we can date volcanoes, we can date floods, anything that puts a scar into a tree or puts a reasonable record into the tree that we can read. Tree rings are also used for the calibration of the carbon-14 time scale, because we can provide the carbon-14 people with accurately dated pieces of wood, which they can run through, see what their readings are, and then adjust their machines accordingly for dating material for which there is no other way to date. So tree rings from the White Mountains in California are helping calibrate the carbon-14 scale, which is used worldwide. So even though the trees, the chronology in the White Mountains is unique only to that area, the applications are worldwide. And as a result of carbon-14 and the tree ring corrections to carbon-14, the prehistory of Europe had to be dramatically revised as to what was first and what was second and what was third. When we are working with tree rings and trying to develop long chronologies, you start with the living trees, where you know what the outside date is. You take cores from those trees, and you don't take it from just one or two, but you take it from many, and you average them together. You make sure that they are all telling the same story. And since in most places, not all, but most, the width of the tree rings is determined by the amount of available moisture, then you are looking at a climatic record, but you're seeing the pattern, and as long as that pattern is repeated from tree to tree to tree, you can be sure you're looking at the same pattern. So we can go back for about 5,000 years with living trees in the White Mountains, but then there are dead trees, there are snags, there are logs, and then chunks and pieces on the ground. And we can overlap those patterns with the living tree patterns and extend the living tree pattern far back beyond any living tree. So at the present time, the oldest known living tree is right at 5,000 years in age, but our tree ring record goes back for 8,800 years in age because we have the overlapping patterns. Then there is a gap, and then we've got another 3,000 years of record that, if I can find the piece that goes in between, then we will have extended our chronology back for 11 or 12,000 years. This piece is one that is right here, is 8,827 years old. It's 6,827 BC, and then you add on 2004 to that, so it's actually 8,831 years ago. This is the oldest dated piece of bristlecone that we have at this time. We have older pieces that are 11,000 years old, but we can't match them yet because there's a gap. This piece, when it was a living tree, the center of it was well away. It would have covered our gap very easily. This tree probably started growing 12,000 years ago. But the inside has gone, it's rotted. I believe a fire came through and took out the inside of it, hardened the wood, but here it is. We've still got this, and this is good, solid wood, which is just lying on the ground and has been lying out there at least for 7,000 years, probably 8,000. I screwed up this summer. I oil my microscope, and now I can't get it to stay at the proper. I got to take it in and get it worked. It was really stiff. It was really hard to move. I put a little WD-40 in it. Boy, did I smooth that out. Now, there's a buddy of mine who cleans microscopes, so I'll take it in. I need to go in and purchase a new bulb for the lamp. I'm counting the rings, and every time I get to a ring that is smaller than the ones adjacent to it, I will put a line down on the graph paper for that ring. So the 10th ring over, the 20th, the 30th, 40th, 50th, so on. The 13th ring over was quite small, much smaller than the ones adjacent to it, so I gave it a long line. 8 and 9 were, they were there, but they weren't that small. 11 was just a little bit small. 35 was quite small. 49 and 50 were small. The longer the line, the smaller the ring. And I make a mark on the wood at the 10-year intervals so that I don't lose my place. Okay, that has done 115, but I always do 2 strips because that way I can be quite sure. Takes time to go through. But if we can date this, which I'm reasonably confident that we will, this will be the quickest method of dating as well as the cheapest for dating stuff in the past. I have sent material off for carbon-14 dating, and I might get it back in another month or 2. And you know, I think if ever I'm going to hold hostages, and I'm going to hold off the Texas Rangers or whoever, which is what he was trying to hold. Skin in a very thin aluminum house trailer. Fortunately, never came to shots, but it was a standoff for a number of days, and he's now in prison and will be there for a very long time, and he never did pay me.
Really?
So if you'd like to buy that piece of wood for what it cost me, well, same thing. It's getting approximately the same heights on the skeleton plot, but that's not critical so long as it's approximately the same height, but the spacing, getting it on the proper ring, that's critical. So I'm transferring this so the computer can look for where it goes rather than my having to run it over a chronology that is 7,000 years long on this particular case because of where this was collected. This one was collected off of Campito Mountain, which is in the Whites of California. So again, the longer the line, the smaller the ring. And every ring gets a vertical line on the graph paper, but only those that are smaller than the adjacent ones get a line drawn. Which goes back to 5,230 BC, or 7,230 years ago. I've got my skeleton plot up here. I go to procedures, I say cross date, and I say find the best match. And what it's looking at is this portion right through here, and then the question is, do I believe that? And I look at this and I say, well, I'm not so sure on that. So if I don't like that, I can say find the best segment. And it's going to try to find the best 40 years. And it's finding this, which looks much better to me than that other one did. So let's just check over and see what. So that's coming through, that's coming through, that's coming through, this comes through. This we don't have, but we do have that, we have that. And there are some problems there, but that's going to be where that goes, because that's good. That's good. And through there. So this has an inner date of minus 3,325 for this piece of wood. When we get through, we can say done. Then we can go and if we wanted to put in, see if we had some missing rings, we can move things over one ring at a time and see how they look. Because a tree does not have to put down a ring every year. But that part comes through quite nicely. There's always problems with trees, and this is no exception. But we will here come and set ring for the first year, and we put minus 3,325. And we've got that, and we can save this. And we will write those down and put them in the book, and then I will go on, because this is 5,325 years old at the beginning ring, and in this case I'm interested in stuff that's 7,500 years old. So it would have to be 2,000 years earlier than this, and obviously on this specimen where I started right here, I do not have 2,000 more rings. So this one will go in the files, and that'll be it. Did you want this in? Okay. So right here where that pencil mark is was where I started plotting, and that is 3,200 years ago. And I need stuff that is 5,000 years, or this is 5,000. I keep forgetting on the, you got to add 2,000 because this is BC. This is 5,300 years ago, and I want stuff that is 5,000 BC, or 2,000 years earlier than this. And obviously, right here is the innermost, and there isn't enough room there. There's a couple hundred years for another 2,000 years. So this one will go in the books. We know where it is, where it was found on the slope. We know what the basic dates are, and we know it's not of interest to me. Someday in the future, someone else may desperately want a piece of wood that covers this time period, in which case they've got it. But the other thing on this is we dated this in just a few minutes. Plotting, surfacing, plotting, dating, and no other dating technique can date things this quickly, this accurately, unless you have an inscribed incision of a date. And 5,300 years ago, very few people can read those dates anymore. Tree ring material is used to calibrate carbon-14 samples, and there is an error, and carbon-14 comes up with a date that is plus or minus, and the further back in time the greater that plus or minus is. And the original assumption was that there was a constant supply of carbon-14 into the atmosphere, and we now know that that is not correct, that there is a fluctuating degree of carbon-14 that's produced, which is then absorbed by all living things, and then after they die they start decaying at a known rate. And Willard Libby, who came up with the original carbon-14 dating, got the Nobel Prize for it, provided all of the original researchers with chunks of wood that he said what the date was on the wood. And finally one day somebody asked him, well, how do you know what the date is on these pieces of wood? And he said, well, when I was a little kid, my dad built a fence in the backyard, and I know the date he built the fence, and this is the wood from that fence. So I got the job of cutting out the same tree ring from one piece of log, which fortunately was quite large, and providing every carbon-14 dating lab in the world at that time with the same date, a piece of wood from the same year that they could use for calibrating. And if you try to cut out an individual ring you would not use bristlecone. I use Douglas fir with quite large rings, but that is tedious job trying to do it. Well, I'm retired from the University, Arizona, tree ring lab, but this is one of these projects that you never are quite willing to turn loose of. So for years after I retired, I continued to work on the bristlecone because we have this gap. We have a long record and then a gap and then another long record, and we know from carbon-14 the gap's was about 300 years and trying to fill it in. So I was going up paying for the work out of my own pocket. My wife and I would go and we would spend 3 or 4 days collecting, and there would be times when there would be other tree ring projects in the Sierra Nevada, and I would go work with them if they would stop by the Whites on the way back to Tucson and help me for a day or two. But then in 1999 at Christmas, we had a Christmas party here at the house, and the gentleman, Malcolm Hughes, who was director of the tree ring lab at that time, came to the party, and as he walked in the door, he looked at me and informed me that he had secured at least $50,000 for my use on working for the bristlecone. As a result, I was able to go to the Whites and spend longer. And because I could go and spend longer, friends started coming to help me. And then friends of those friends started to come to help. And then people who just heard about it came and started helping. And this last summer, I had 45 people in the field. I was providing financial assistance at a very minimal rate to about 5 of those people. That was mainly gas and some food to get over and back. The rest of them were coming out of their own pocket. We had 4 people from Wales this summer. The previous 3 years, we had a couple from Finland who did not come this year because the Olympics were on, and they went to the Olympics, darn them. I wanted to go to the Olympics too. But I'm sure they'll be back this next summer. So all over the United States, many of my friends, but again, people that I know, and then people that they know, and then people that know those people have been coming to help at their own expense, and I have them going out in the woods with GPS units and digital cameras and looking for the tags that have been put on specimens since the 1960s. And the original tags were thin aluminum like this. And you could punch these out in the field and tack them onto the tree. But after these started being put on in the 1960s, and after 40 years, these are really suffering from wind gets under them and wiggles them and pulls the nails out. Birds peck on them. So we've gone to a heavier gauge tag, which we nail on now. We're hoping that that will last. It'll last my lifetime, I know that. So I have people going out and relocating these tag trees, our logs, our fragments, and when they find a tagged specimen, they take a small whiteboard, write on it what the tag number says, put it in against the specimen, and they take a digital photo of it, and they have the GPS of it, and all of that is recorded, so we have a permanent record of where each of these specimens is in time, in space, and something that we can go back and relocate in the future, because we never know which one of these we need to go back and relocate. One of the interesting problems that we have is when Dr. Schulman was working there in the 1950s, he never put a tag on anything, but he did take photos, and on some of those photos he labeled them, because this is a big problem. You go out, you have to get the film developed, you get the film back, then you have to figure out what tree it was and put a label on it, numbers on it. But on those where we have found a photo which is labeled, Then I make copies of those photos, and people go out in the woods with a copy of the photo until they find the tree. And this is literally finding a tree in the forest. I did not know how successful they would be, but it has been really amazing to me what they can find, because in many cases you have to be on the precise side of the tree that the photo was taken from before you will recognize it. You can be on the opposite side and just walk right on by. And on the finding the tags, many of my volunteers refer to this as Easter egg hunting. They have a lot of fun, and they keep coming back.
Did something right.
And the only problem I have is in the early morning, before I've had my first cup of coffee, and people show up and want to know, where do you want me to go today? The immediate response is to tell them to go to unprintable places. But they have learned, and one of them has set up a whiteboard with a list of tasks that need to be done, and they can look at that and check off. This is a report that I gave to the Forest Service from this last year's, for this last year, but this is a report on everything that I've managed to relocate, starting with Schulman's stuff in the 1950s and coming on up to my work. And so here's an example of the log, quite large log, a whiteboard with the tag number, the latitude, the longitude, the date, and who collected. And this log happens to be one that is 7,500 years old. So in many cases we're not looking for just little fragments, we're looking for big pieces. And in this book there's every bit of data that I have been able to find in the files as to who collected, when, where. So there's a specimen number, a year, a specimen number, the collector, the date of collection, where they collected, any information that we have on the collection itself, what the dates are, whether there's carbon-14 dates as well as tree ring dates, whether or not we have a GPS on it, whether or not what the substrate is. Same specimen numbers, whether there was an original photo, whether there's a digital photo, whether it's a core, a section, and what box it is wound up in. And the box is something that I am going through now, all of the boxes in the storeroom, finding out what's in there, what it was collected, and then we can put the box number. Obviously, I've got a lot more work to do. The original photos are here. We have not relocated these as of the time that we went into the field. If they are relocated, then it will be marked as a digital photo. And this goes on and on and on. But this is all the bristlecone all over the West that I've been able to find any records of. And at the end of the book, I've got a CD which has all of this same material on access, so you can pop it in the computer and look up using the find functions and access to say, I want only those specimens from a particular site on a particular date. This CD has the photos that are referred to in this book, and this CD is full. The next report will either have a second CD or I'll have to go to a DVD. And what you can do with all of this is you can print out a map with a single specimen that you're looking for and where it is located, all of the other specimens that were collected that year, which are the same thing, all of the collections in that area but blown up with the one we're looking at highlighted in red so we know which one to look for, with the trails shown in the proper place with trail markers, the latitude, the longitude, the dates. So this one has an inner date of 6685, and here is the photo of what that specimen looks like lying in the field with the whiteboard, but in context. So you can use a GPS, you can take the data from this book, you can take your GPS and get back out to the same place, and then with the photo you know exactly which log it is out there, because the problem has been, how do you define a chunk of wood lying on the floor of the forest where there are literally many thousands of other chunks of wood? And this project is made possible by GPS, digital photos, and many volunteers. Copies of this report have gone to the United States Forest Service, to people in the Tree Ring Lab, to people in Montana, to people in Colorado, to people in Finland. I try to get it widely spread so that if anything happens, you don't have just a single copy somewhere that's lost. You've got this data somewhere and it's going to survive. And I can only, since I'm doing this out of pocket, I can only afford to do, I did about 10 of these this year. They're running, probably 25 bucks a piece, which if you're going down and buying a book, that's not too bad. But when you're paying for it to give to somebody else, then that causes more of a problem. And I can only hope that the next person who comes along will find this of value and continue, because you never know. I mean, if something happens to me and the project is over and they get somebody else to pick it up eventually, will they start all over again? Will all this be lost? I hope not. I would hate to think that I've spent all this time and effort putting this stuff together and then have it go down the tubes. But I have seen many projects where that has happened. So it's always a possibility.